Hello, and welcome to Blueprint's latest webinar. For those unaware, Blueprint is a strategic consultancy focused on additive manufacturing. We have 15 years' experience working with hundreds of customers in virtually every industry across all additive technologies. We've done engagements ranging from high-level strategy and innovation to deeply technical design optimization at startups and Fortune 500 companies alike. Simply put, we're laser-focused on helping our customers make sense of 3D printing. In today's session, we'll be discussing how 3D printing can streamline your supply chain. So let's start with some quick introductions. My name is Kunal Mehta, and I'm the global head of Blueprint. I have over 13 years working experience in consulting, focusing on the overall strategy and implementation of emerging tech and trends, from cloud computing to artificial intelligence and customer experience to now additive manufacturing. I've led hundreds of projects from concept to delivery. Shortly, I'll be handing off this webinar to my colleague, Oliver Smith. He is our resident innovation guru. With a focus on human-centered design, Oliver helps our clients understand how to use AM outside of the box, how the technology can drive growth, how the technology can be used to create new products, and fundamentally change how a company manufactures. If you have interest in reaching out to us, please reach out to hello@additiveblueprint.com, and one of the team will reach back out to you. Before we get started, I'd like to remind everyone that this webinar episode is part of a much larger ongoing series on the business benefits of 3D printing. Each episode, including this one, focuses on a specific business benefit of 3D printing, allowing us to go deep into each area of opportunity. If you want to watch the series from the beginning, as well as watch our first episode that describes the 6 drivers framework that we're about to explore, then visit the website or reach out via email and we can share it with you. For those new to this series or unfamiliar with Blueprint, I'd like to briefly describe our 6 drivers framework. This is our fundamental methodology for how we understand and teach our clients to understand the world of 3D printing and how it impacts and benefits businesses. So what is it, and how does it work? During our many years of consulting with industry partners, government agencies, and academic partners on 3D printing, we slowly began to recognize patterns. More and more of our recommendations, solutions, and results from academic work would touch on recurring principles. It seemed to suggest there was something more fundamental under the surface, a bedrock from which all of our work was sitting on. So we decided to dig, and we decided to dig and dig a little bit more. And after reviewing, critically comparing, and codifying, we formed, or you could say discovered, the 6 drivers of business value. In essence, it's 6 fundamental and distinct principles for how 3D printing impacts and adds value to a business, industry, and the world we live in. And in this episode of the 6 Drivers series, we will take a deeper look into driver number 3, streamlined supply chains. We will look at how 3D printing, as a digital and a highly flexible manufacturing technology, is enabling manufacturers, logistics providers, and customers to reshape their supply and distribution chains. So this is where Oliver will take over and unpack this particular driver in more detail and walk through some very interesting industry examples that we've seen over the course of the years. With that, Ollie, the mic is yours.
Thanks, Kunal, and hello to everyone watching. As Kunal said, my name is Oliver Smith, Senior Innovation Consultant at Blueprint, and over the next 15 minutes or so, probably a little bit longer, I'll be walking us through one of the 6 drivers, namely streamlined supply chains, and showing you not only some interesting examples of this principle in action, but also methodically examining how this single driver can enable fundamental business change and business innovation. So, before we proceed on this journey, I think it pays to understand where we're starting from. The words 3D printing and supply chain are very popular on Google search trends at the moment, and it is a very popular area for discussion and debate amongst technology vendors, manufacturers, logistics providers, consultancies such as ourselves. Even government policy makers are talking about this stuff. And this is understandable when we consider that 3D printing does have the potential to disrupt the very fabric of our highly interconnected and globally dependent society. In today's world, most of the products you own, the materials in your house, even the food that you eat, has probably travelled more miles around the planet before it gets to your living room, backyard extension, or your mouth than you may travel in a full year. So the idea of a new technology coming in and upending this global paradigm is both provocative, but prone to hyperbole and wildly different definitions depending on who you may ask. So from our many years of consulting global logistics firms, international manufacturers, even working on government policy papers, we created a simple and concise definition of our own, which we think distills all these viewpoints, white papers, forecasts, into their purest expression. And it is this. As a digitally driven, on-demand manufacturing process, 3D printing allows for the radical rethink and reconfiguration of how companies structure their internal processes, distribution channels, and supply chains. This is how we, at Blueprint, define streamlined supply chains in a nutshell. So consider it your one-sentence response if you're ever at a conference or at a bar and someone asks the question, what is going on with 3D printing and supply chains? Now let's go one level deeper. We defined the what in that 3D printing has the power to radically upend traditional models of supply and distribution. That description I just gave you is a great top-line descriptor for what streamlined supply chains are. But now let's look at the how. How does this happen? So behind the driver, streamlined supply chains, as with the other 5 business drivers in our framework, we have detailed a number of tactics. These tactics are real-life expressions of their associated driver. In this case, we're looking at streamlined supply chains. Think of the drivers as core principles for how to think about 3D printing, and their associated tactics as the methods in which to apply each principle in the real world. So for streamlined supply chains, we have determined that there are 10 discrete tactics in which this principle can and is being applied to industry. So some examples of this are Divergent 3D, for example, the photograph of the car. And they are an automotive startup founded in 2014 who are developing micro factories that can set up at any location, run self-sufficiently, and not have to rely on the global supply networks as all other automotive incumbents and manufacturers must. Not only does this make them more flexible in their production runs, more responsive to changing market needs, but also less dependent on volatile global supply networks and the fluctuations and risks that come with it, such as tax changes, import and export delays, and trade embargoes and tariffs, something being keenly felt by some North American automotive companies right now. In an entirely different industry that's moving in a different direction, Leica, the bottom right-hand image, are a stop-start animation film studio, and they are leveraging the ability to 3D print fully coloured, highly detailed facial expressions for their stop-start figures. I can testify to how fantastic and laborious that sculpting these are, given my history as a model maker myself. What was a highly labour-intensive and craft process that took significant time has now been consolidated into a fully digital process to both reduce production time whilst also allowing for a much greater number of facial expressions to be designed, printed and included in the animation in the film. So to give you some numbers, a traditional stop-start animation film relying on traditional handcraft methods might use, say, 800 facial expressions in the entire film, whereas Leica's latest film, Missing Link, 3D printed 102,000 faces. That's one face for every character for every frame in the film. Now, it would take hours to drill down into each of these tactics. So for this webinar, I'd like to focus on 2. I'd like to pick out two tactics in particular. And it is these 2 that I personally believe, and from what I can see happening in the media and industry, are the ones where most of the conversations around 3D printing and supply chains are being had. So I feel almost obliged to weigh in and try and bring some sense and logic to these particular 2 concepts. One of these is the premise that 3D printing is going to eliminate the warehouse through virtual inventories. The traditional image of cavernous warehouses with towering shelves of stock will be a thing of the past, and instead it will be replaced by 3D printers producing components and parts from a digital inventory sitting in the cloud. So to get a reality check on this idea, we'll look at a rail repair centre in Germany. And the second tactic we'll explore is manufacture line-side or at the point of use. Now this tactic goes by many other names and themes in the wild, such as decentralized manufacturing, local manufacturing, on-site production, printing in the field, and so on. So to see how viable this notion actually is, we'll step into a war zone, where making what you need where you are is far more preferable than moving things to your location across potentially hostile territory. So let's jump in and start with our first tactic that we'll explore, manufacturing line-side or at the point of use. Now, as I just mentioned, there are many concepts for producing parts closer to where you need them, whether that's microfactories that are situated across a city servicing local users and businesses, or 3D printers positioned along a production line environment, producing parts in a just-in-time meets Kanban style of inventory replenishment methodology. The keywords to look out for when discussing this concept are things like decentralized manufacturing, onshore manufacturing, and localized production, words of that nature. Now, many different definitions and descriptors exist, but we define all of these as the tactic, manufacture line-side or at the point of use. And we define this tactic as such, quote, many manufacturing methods require parts to be produced in volume or in locations far away from the point of use. Using 3D printing, you can produce parts on demand in lower volumes and in less space, which means you can manufacture closer to the point of use or need. The benefits of having your supply chain configured in this manner are many. If we expand the idea of the example I just gave, microfactories within cities, for just a moment, we can quickly realise some interesting benefits both for the individual businesses and the larger city and community. On the community side, localised production can be a potent job engine for local economies. This is very important, especially in today's current age, and this would be a reverse shift in the prevailing approach of centralise and recruit and then ultimately offshore altogether. And if we scale up our perspective from local level to international level, the production of product to service local communities can some way help to offset the need to transport products and parts over very long distances around the globe. But instead, we can move raw production materials to those local production centres. This being, or moving raw material, can be achieved more cost effectively and space effectively, providing a reduction potentially to your environmental impact. If we turn our head towards the business angle of this, the ability to 3D print complex parts or even entire products in a single, automated process driven by digital data vastly reduces the requirements for manual assembly processes, as well as the management and carrying costs of sourcing and storing parts from multiple suppliers. Furthermore, as a toolless production process, your local factory can become much more agile, and it can become an agile production platform responsive to changing product demand or quantity demand by the local market. A concept quite elegantly demonstrated today by the company Local Motors, who are using 3D printing to provide a more responsive solution to producing cars and special purpose vehicles. To do this, they are creating microfactories across North America with 3D printing as the production technology of choice due to its flexibility in adapting to changes in production runs. But there are also limitations and some significant barriers to this concept of manufacturing at the point of use. The primary barrier, as is typically with most 3D printing applications, economies of scale. And to solve this, you need to have a very well-defined set of metrics for how you can expect to see value returned by decentralizing or moving your production capacity. Now, the benefit of centralization is consolidation of costs in equipment and operational costs. To decentralize, to spread all of your production across your region, means to duplicate. You have to buy a set of equipment for each site and then hire staff for each site. By centralizing processes, you may still need the same amount of hardware equipment, possibly slightly less, but you can be sure to gain better utilization of that equipment, as well as run a much more smaller, more effective agile operating staff. So all in all, this particular tactic is complicated. It is pretty unlikely that you are going to see any financial benefit by simply repurchasing equipment and moving it closer to the point of consumption, picking up your production center and either dividing it up or moving it somewhere else. The key here is to define a metric for measuring value, finding a concrete reason, opportunity or pain point that can be addressed by manufacturing closer to the point of use. Local Motors found their value metric, which was agile response to local market needs. What other metrics are there? Let's look at our first case study. Of all the reasons to relocate your manufacturing closer to where you need and use the parts, being shot or blown up is a pretty good one. What I'm talking about is moving goods back and forth within a war zone. The North Atlantic Treaty Organization, or NATO as most of us recognise it as, defines this process of procurement, receiving and storing and distribution of material, such as armour, weapons and provisions, within a war zone as in-service logistics. That is the name given to moving parts across a war zone. Now, first, a brief and simple history of military logistics. Historically, wars have been focused on sovereignty, acquisition of land and resources. In these kinds of wars, there are well-defined fronts where conflict takes place. These may move back and forth, but they exist as perimeters between two opposing forces. These perimeters allow you to continue to operate behind that perimeter, and because of this, you can create stable, safe supply chains to funnel resources from your region to your front. So as long as you can maintain production in your country and ferry resources to the front line, you can maintain or advance, say, your position. But in the modern era, guerrilla tactics are the modus operandi of most conflicts. Lessons learned from the Vietnam War, Gulf Wars, and Iraq War have shown us that in today's world, there are no fronts. No defined perimeters where conflict occurs. Instead, a war zone becomes a nebulous space where your enemy can be anywhere, appear from any direction, and engage you on any front. In this scenario, the idea of an opposing force relying on arterial supply chains, running resources to the front, falls down when there is no front but a region of conflict, and that supply chain itself is now as exposed as your frontline troops. So, how is this relevant to our conversation? Well, in today's world, troop deployments need to be ever more self-reliant and less so on having material ferried to their position when they very well may be cut off from any reinforcement. The Nibbler is a great example of this principle of self-reliance in action. Pioneered by the US Marine Corps and MITRE Corporation, the Nibbler is a 3D printed drone, or UAV, that can be constructed in the field through a combination of 3D printing and basic electronics and hardware. In short, it is a drone that can be manufactured in the field, using a low-tech 3D printer and some basic equipment. The Nibbler is part of a larger program from the US Marine Corps on how expeditionary forces operate in the 21st century, with one focus being on in-service logistics and localized manufacturing and sustainability. To quote Marine logistics expert Lieutenant Colonel Howard Morado, quote, "On demand, as needed, closer to the point of need. That's something we don't have. We assume when we forward deploy, we bring every single thing we need, just in case. The assumption today is that the supply chain may or may not support our needs," end quote. Nibbler's story actually starts in an in-flight magazine being read by Marine Corps Sergeant Jonathan Gillis in 2015. He read an article about the concept of swarm troopers, a military concept for how swarms of drones are going to become a defining feature in 21st century combat. This brought him to the attention of MITRE Corporation, a not-for-profit federal R&D centre who were experimenting with this idea of low-cost 3D printable UAVs that could be manufactured in the field. Seeing the potential, the Marine Corps partnered with MITRE to further develop the concept of low-cost 3D printed drones, culminating in the Nibbler. So how does this drone work? The entirety of the drone costs around $2,000, with the body of the drone itself being 3D printed, and then the electronics, GPS, camera, processors, all being manually integrated. And to increase its versatility, the electronics and hardware of the Nibbler can all be stripped from a mobile phone. The drone itself has a flight time of up to 20 minutes or so, more than enough time for it to conduct its operations of local surveillance. And with all this information in mind, you can understand why General Robert B. Neller, Commandant of the Marine Corps, had the confidence to stand up and say, quote, "At the end of next year, my goal is that every deployed Marine infantry squad has their own quadcopter." But MITRE went one step further than just making these nibblers. They decided to teach the Marines how to 3D print and build the drones themselves, and empowering them with the ability to manufacture these small UAVs in the field when and where they need them, rather than rely on a distant manufacturer to produce and deliver to order, with all the limitations of time and risk of attack that comes with a military supply route to a location that might not even be accessible due to hostile forces or geography. Captain Chris J. Wood of the Marine Corps' Innovation and Logistics Branch described how powerful this approach to in-service logistics can be. Quote, "Imagine being in a forward-deployed environment, and just like Amazon, you can click and order the weapons and equipment you need for the next day's mission from an entire catalogue of possible solutions. These solutions can all be upgraded literally overnight in order to integrate new components or adapt to new requirements. On a very small scale, Nibbler shows us that this is possible right now." End quote. So what are the metrics at play in this case study? How is the Marine Corps seeing value by, to quote Captain Chris J. Wood again, a small manufacturing capability locally? Firstly, there is a safety and supply argument. As I mentioned previously, supply routes in today's war zones are incredibly hostile and unpredictable, so eliminating the need for land and air supply routes can help to reduce putting soldiers in harm's way, a value that I personally believe no one should undervalue. The second metric is versatility and adaptability. 3D printing is a toolless technology, allowing you to produce different parts and products. Having this production flexibility in the field means that warfighters can produce UAVs to meet the exact requirements of the present moment. The Nibbler design itself is designed to be infinitely configurable, accommodating other equipment or being changed to meet different operational requirements. To quote Andy Chapman, head of the Nibbler program at MITRE, the normal acquisition process is like a giant game of telephone, if any of you have played that game. Years may pass in that process, and by the time the system is finally delivered to the warfighter, the world has changed. The system no longer matches the warfighter's needs. By putting this technology into the hands of the Marines around the globe, they can identify and feedback what they need, and continue to be innovative as they use the equipment. Close quote. And the final metric is cost. Does this centralized approach to producing UAVs save the military and ultimately the taxpayer money? When considered in the long term, the answer is yes. The Nibbler and its variations won't take the place of a Pentagon contracted military drone. But the versatility and low-cost nature of the Nibbler drone's materials and construction still make it orders of magnitude less expensive than military UAVs with comparable performance. So there is a unit cost reduction, but there is also an operational cost saving. Aside from the cost reduction brought by eliminating the need for costly military supply convoys to get the drones to where they're needed, to quote Captain Chris J. Wood, quote, "Ultimately, it's about optimizing specific mission needs to the equipment we use to fight those missions. Additive manufacturing and localized manufacturing allows us to do this at a scale and speed never before seen." Close quote. So, to summarize this case study, more in the context of the industrial world that we operate in, what the Nibbler story tells us is that to make the tactic of manufacturing live side or at the point of use work, you need to have determined a distinct and significant pain point or opportunity that could be addressed by relocating your production. In the nibbler example, if we replace some of the military language for industrial terminology that we're more familiar with, the pain point was responsiveness to local demand, a need to meet rapidly changing and highly localized requirements, and a response to a much larger trend in the marketplace. In Nibbler's case, it was a response to the rise of improvised drones being used by guerrilla forces. So now let's move on to our second tactic, stock mitigation and digital inventory. As with the last tactic, this one has become a hot topic in the last couple of years, particularly with the increasing prevalence of Industry 4.0 and digital factory and all the conferences and seminars and strategies that come with that. From phrases such as cloud-based inventory to zero inventory, print-on-demand parts, all of these terms can be summarized by the tactic stock mitigation and digital inventory, which we define as such. 3D printing allows you to free up working capital that is sitting in inventory. Converting some traditional inventory to digital inventory, which can be printed on demand, can reduce the amount of capital tied up in slow-moving parts. A simple concept, and one that ties into multiple approaches to inventory management, from just-in-time to fast, slow and non-moving to vital, essential and desirable. There are many methodologies for better managing inventory to ensure you have exactly what you need in the correct quantity. So the concept of eliminating your physical inventory altogether and instead replacing it with a cloud-based print-on-demand system is the holy grail of inventory management. So how viable is this idea in reality? Are we really at a stage where we can start 3D printing parts on demand rather than buying in bulk and storing in a warehouse? To test this hypothesis, Blueprint, in collaboration with IBM, conducted a project to determine the viability of such an idea. One of the experiments centered on the white goods industry, washing machines, home appliances, that sort of thing. A prime candidate for 3D printing inventory and replacement parts, that industry has a high number of replacement and spare parts demands. So we first dismantled a standard washing machine into its constituent parts. We then removed all the composite parts, electronics, wiring, rubber gaskets and other parts that cannot be commercially 3D printed today due to size or material limitations of today's 3D printing technologies. We then reverse engineered the remaining printable parts and conducted an economic analysis to determine the costs of printing these components. The end result was an incredibly expensive washing machine, with the total cost of printable parts 150 times that of their current procurement costs. So, with this information, consider the fact that Whirlpool, the world's fourth largest white goods manufacturer, is fully committing to 3D printing as a technology to streamline their inventory. So based on the numbers in front of us, how does this make sense? In a review of 11,000 SKUs, Whirlpool identified 7% of these as economically viable for 3D printing. That's 770 unique parts. And their success, like the Nibbler case study shows, is that you need to be able to pick the right metrics for defining how you are going to see value. In Whirlpool's case, they believe that 3D printing can help to mitigate the costs of obsolescence and spare parts. Franco Secchi, head of consumer services and quality for Whirlpool EMEA, said, quote, "I know we won't make large production batches with this technology, but there is an excellent value to solve obsolescence and shortage issues, which generally fold into low volume demands. This way, 3D printing can have direct, significant impact on our customer care." Close quote. So the key to Whirlpool's success is identifying a subset of inventory that is ripe for digitization. But as with the Nibbler case study, it helps to combine multiple value propositions to make your 3D printing initiative return more meaningful value. Not only have Whirlpool determined that some parts in their catalogues can be economically 3D printed based on the demand volumes, but the nature of having these parts stored digitally means there is no risk of the parts becoming unavailable, as they can be printed out using the digital file whenever needed. This superior legacy support is another value that can be passed on to Whirlpool's customers. So this is one example of how stock mitigation and digital inventory can work to minimize indirect obsolescence and to help reduce costs from last buy orders and extend almost indefinitely the provision of legacy customer support. So now we have a good understanding of what stock mitigation means, let's turn to our second main case study in this webinar. We've seen how Whirlpool utilised stock mitigation and digital inventory to minimise the costs incurred from obsolescence and improve customer support for the products by maintaining a digital catalogue of consumable and repair parts. We've seen it work for washing machines. Does this driver still apply when we scale up from washing machines to 200-ton trains? Well, Siemens Mobility, one of the world's largest rolling stock manufacturers, answered this question, and the answer, as they determined, was yes. But again, the key to their success was defining value beyond beating traditional part costs, as the biggest barrier to this driver, as I have mentioned again and again, is economies of scale. They looked for very specific parts, applications and pain points that could be economically addressed by 3D printing via a digital inventory. So what's the story here? Siemens Mobility services a lot of locomotives. Their RRX Rail Service Centre in Germany services around 100 trains a month, all of which can be discretely different specifications or wildly different models and ages. The service logistics and inventory management to support this volume of locomotive servicing was, and probably still is, a challenge. As Michael Kurtzmig, head of additive manufacturing at Siemens Mobility Germany, describes the situation, quote, "Every train has to go through maintenance several times a year. As you can imagine, all of our customers would like this process to be as quick as possible, but they still expect maximum levels of detail, safety, and quality in the work that we do. We also have to consider unplanned or last-minute jobs, and if you look at the different train models and companies we service, this requires a lot of customized solutions." Close quote. So this demand for service quality and efficiency by Siemens Mobility customers, coupled with the high degree of variation in age amongst the locomotives coming through the service centre tracks, was the trigger for looking at a more streamlined service and inventory solution and the pain point that goes with it, and that they turned to 3D printing to try and address this issue. Siemens' approach to identifying potential parts and processes that could be streamlined with the digital on-demand inventory system was novel, to say the least. Whirlpool's approach was highly quantitative, analysing strings of inventory data and SKU catalogues. Siemens' approach was far more qualitative, implementing a grassroots initiative of shop floor engineers and staff to submit their ideas as they saw them for operational improvements, with the focus being on 3D printed parts. Now, this shop floor level approach, combined with the more traditional data-driven approaches like Whirlpool used, culminated in many thousands of concepts, and after rigorous down selection, redesign, validation and economic analysis, 450 different components were added to a digital print-on-demand inventory library. So what were the metrics used to determine value? How did Siemens overcome the economy of scale issue that is the biggest barrier to implementing a digital inventory system and find these 450 different parts that make sense? Well, the RRX Service Centre processes up to 100 locomotives a month, with a wide range of variability amongst them. This uncertainty of what may be rolling through the door next necessitates that Siemens keep a large stock of a high number of different parts and components, as Siemens is incentivized to perform maintenance as quickly as possible. The need to keep this stock has multiple disadvantages. Not only does this approach create a vast amount of tied-up capital locked up in your inventory, some of that inventory may hardly ever be used or may even be scrapped. And secondly, when providing a maintenance service to customers with such a wide range of unique requirements and needs, it is 100% impossible for your inventory to guarantee availability of the correct part at the right location when needed, creating maintenance stop issues and ultimately delaying getting the customer's locomotive back into service. So the underlying issue is that their inventory management could not demonstrate the required flexibility and agility that was required for the variables, one-offs and customer-specific needs faced by their maintenance processes. So the key metric for proving value from a print-on-demand digital inventory was flexibility and agility, not necessarily trying to produce parts cheaper than traditional production processes that benefit from economies of scale. Michael Kurtzmig again makes the same point, quote, "The ability to 3D print customized tools and spare parts whenever we need them with no minimum quantity has transformed our supply chain. We have reduced our dependency on outsourcing tools for our suppliers and reduced costs per part, whilst also opening up more revenue streams by being able to service more low-volume jobs cost effectively and efficiently." Close quote. So, to summarise our Siemens Mobility case study, we can make a couple simple determinations. The first is that inventory is an unhelpfully broad term and used far too flippantly when discussing the idea of digital inventories. The smart approach is to segment your inventory into silos, such as assembly inventory, service inventory, upgrade inventory, tool inventory, spare inventory, and so on. Taking this approach allows us to appraise each of these silos more precisely and identify the unique issues for that particular subset. In Siemens Mobility case, inflexibility within their service inventory. That was the unique pain for that particular subset. The second point is, as I mentioned, economies of scale will forbid us from making sweeping digitization of your entire inventory based on beating part cost. You need to find a specific value, benefit, or pain point. Whirlpool, in their example, identified that having to maintain stock to combat obsolescence could be addressed by a digital inventory, where the 3D printed parts themselves may be more expensive part per part than traditional manufactured versions, but the ability to manufacture in low volume and as needed rebalanced the value calculation in 3D printing's favour, as you are only paying for what you need rather than being restricted to minimum buy orders or lost revenue from written off parts due to over forecasting, let's say. To put a fine point on it, when looking into stock mitigation and digital inventory, go granular and look for value in the total cost of a part and its lifetime costs, not just the production cost of the part. And this brings us to the end of our webinar on how 3D printing is helping to streamline your supply chains. Now, I really want all of you to think about how this driver applies to your situation, to your business. We've seen two different faces of this driver in two very different environments, from a war zone to a locomotive shop, to probably the furthest away industries you can get. And in both cases, 3D printing is having real material impact on how they configure their supply and distribution chains. And they are, as we have seen, reaping the benefits of doing this by investing and implementing in an intelligent way. And to the bigger, more profound message that I hope you will all leave this webinar and take away with you is that for each of us to stay ahead in our game, to stay ahead of competition, and to be change makers, is that we need to think very differently. The point I made again and again in this presentation is that economies of scale will always work against you in 3D printing, but no more so evidently than within your supply, production, and distribution chains. Which is why we need to think differently, which is why we need to think like Marine Corps Sergeant Jonathan Gillis, or Head of Additive Manufacturing at Siemens, Michael Kurtzmig. Go beyond the obvious and go deep. Find your niche. Find the metric beyond piece part cost that will allow you to leverage the value, the demonstrable value that we have seen of 3D printing. Whether that's moving production closer to the point of need to become more responsive to local requirements and to drive that incremental revenue growth, or maybe implement a digital inventory system to mitigate tied up working capital and increase service quality and customer value and care. In today's world, technological advancement is marching in step with an ever greater expectation from our customer base and growing pressures on a global scale from resource scarcity, global warming, geopolitical instability that we're seeing right now. The supply chain of the 21st century will no doubt have to adapt to these 21st century pressures. And my hope is that in this webinar, it has sparked some thought, some idea in your thinking, in your consciousness about how you can better navigate these inevitable and significant changes by applying 3D printing in some way to help streamline your supply chain. And before we leave, I'd like to quickly mention that we did not go into the other tactics in streamlined supply chains, but if you want to read up on these, as well as the entirety of our 6 drivers framework and all 50 tactics with associated industry case studies, then you can download our latest book, The Little Blue Book of 3D Printing, by visiting our website additiveblueprint.com. This is a great little pocket book if you're ever stuck for understanding how 3D printing could benefit you and your business. And I promise this will give you endless inspiration for you and your team's thinking. So please go online and download and use as you see fit. So this wraps up our webinar, How 3D Printing Can Streamline Your Supply Chains, the 4th episode in the 6 Drivers webinar series. I want to say thank you for spending the time with us at Blueprint to listen and to hopefully learn something new. We really do appreciate you spending this time with us. It's been super fun to present this, and I really hope that you attend the next episode. And if you want to carry on the conversation, then please do email me at hello@additiveblueprint.com. I much prefer receiving emails from people outside my company than people from within it. If you're already on a 3D printing initiative out there, then again, I'd love to hear from you, hear what you're doing, and hear how you're going about it. I'd really love to have that conversation. So with that, I will sign off. I've been Oliver Smith, Senior Innovation Consultant at Blueprint, with my colleague Kunal Mehta, Head of Consulting at Blueprint, and I shall say goodbye, thank you, and I really look forward to seeing you at our next webinar.